All right, let's get started. And so if you recognize this, we've already done this problem. And so in this problem, we want to find the value of each subtraction equation. And by doing that, we understand that we can change subtraction into addition. And so what that means, rule number one says subtracting a positive is the same as adding a negative. And what does that look like? Well, up here, this is 3 minus 2. So we are subtracting a positive, and subtracting a positive is the same as adding a negative. So this is 3 plus negative 2. Notice how we went from subtracting a positive to adding a negative. And then finally, for part B, this is 5 minus negative 9. And we have here subtracting a negative is the same as, and the answer is adding a positive. And so 5 minus negative 9 is the same as 5 plus 9. And so now we can apply those rules going throughout. Negative 11 minus 2, subtracting a positive is the same as adding a negative. So this is negative 11 plus negative 2. For part D, negative 6 minus negative 3, subtracting a negative is the same as adding a positive. So this is negative 6 plus positive 3. So here I have negative 1 and 2 tenths minus negative 3 and 6 tenths. So this is negative 1.5 plus positive 3 and 6 tenths, because subtracting a negative is the same as adding a positive. And then finally, you have the same concept here. Subtracting a negative is the same as adding a positive. So this becomes negative 2.5 plus 3.5. And so to get the values of these, right? And so we start here, we have a positive plus a negative, or a negative plus a positive. Take the sign of the largest numeral and subtract. Largest numeral is 3, and so 3 minus 2 is 1. So this means our answer is positive 1. For part B, 5 plus 9, right? Because we changed it to addition. We already know that's just 14. Part C, negative 11 plus negative 2. We know when we add two numbers of the same sign, you just add like normal. This says I owe you $11, and now I owe you 2 more. How much money do I owe you? Well, I owe you $13, and so that would be negative 13. Here's another example of adding opposite signs. And so this would be a negative plus a positive, or a positive plus a negative. Take the sign of the largest numeral and subtract. And so the largest numeral here is 6. So that means my answer is negative. And so negative 6 plus 3, 6 minus 3 is 3. So negative 6 plus 3 gives us negative 3. And then finally for E, this is negative 1 and 2 tenths plus positive 3 and 6 tenths. So that's a negative plus a positive, or a positive plus a negative. Take the sign of the largest numeral and subtract. And so we line it up by place value, right? Decimals are aligned. And now you subtract 4, 2. And so because 3, 6 is positive and it's our largest numeral, our answer is positive 2/4. Same thing, take a negative plus a positive, or a positive plus a negative. Take the sign of the largest numeral and subtract. So this is 3 1/2 plus negative 2 1/2. The halves cancel out, and 3 plus negative 2 gives us 1. So our answer is positive 1. Let's move on to the next one. All right, so in this problem, we have a mountaineer is climbing on a cliff. She is 400 feet above sea level, well above the ground. If she climbs up, this will be a positive change. If she climbs down, this would be a negative change. And so this is just what a mountaineer looks like. Also a spelunker when we get down here. And so our starting elevation is always 400 feet. And so if you change to go 300 feet up, right, you're just increasing by 300. And so that would mean you're 700 feet above sea level. For part B, you're going 150 feet down, and so you would do 400 minus 150, so you can do that on the side. Bam, you regroup. And so you got that they're 250 feet. And so now you keep going, 400 feet up, up, 400 feet down, you're just at sea level, right? These are additive inverses. And then here you end up at 50 feet above sea level. So how much did you have to go down, right? And you know you're going down because 400 is bigger than 50 feet. And so you're going down, right? You can either do it in your head or maybe you just quickly just do this on the side. Bam. That you went 350 feet down. And so to go from here to here, we're just doing an addition equation. So this would be 400 plus 300 is equal to 700. Quick, another way you could have wrote this, if we want to do this as like subtraction as well, this could have been 400 minus negative 300 equals 700, because subtracting a negative is the same as adding a positive. And so going down to part B, okay, so we starting point at 400 plus how much we went down. And remember, going down, if you climb down, that will be a negative change. So this would be negative 150, which was equal to 250. Part C, you have 400 plus going 400 down, which is negative. And so we can see these are additive inverses because they're opposites, and that just equals 0. Finally, part D, 400 plus 350 feet down is still negative, so that's negative 350 is equal to 50. And so now we can go to question number 3. A spelunker is down in a cave next to a cliff. If she climbs down the deeper into the cave, this will be a negative change. If she climbs up, whether inside the cave or out the cave, it will be a positive change. Complete the table. So here we're starting below sea level. We're starting 200 feet below sea level. So if you go down more, well, you're still going down, so that'll be negative 350, right? And a way we could write this would be negative 200 plus negative 150 equals our negative 350, right? Because you're going down more. And so now you're at negative 200 feet below sea level, but you climb up 100 feet. Well, now you're just at 100 feet below sea level. So that would be negative 200 plus 100 equals negative 100. So you're down 200, you go up 200. Well, these are additive inverses, so you end at 0. And so this would be negative 200 plus positive 200. These are opposites, and when you add opposites together, we call that an additive inverse, and they ended up equaling 0. And so here you started at 200 feet below sea level, but you climbed up 200 feet. And so if this was the surface, right, and you're down here, you went up your 200 feet, right, because this is negative 200, and then you went up 50 more. And so you end up at 50 feet above sea level. And so negative 200 plus 250 just gives us positive 50. So this would be negative 200 plus 250. And what we know is you take a negative plus a positive, or a positive plus a negative, take the sign of the largest numeral and subtract. 250 minus 200 is 50. Largest numeral is positive, so your answer is positive. And then finally, right, we have negative 200 plus some number equals negative 500. Well, clearly we're going down more, and so we went down 300. And so this would be plus negative 300. And that's what we would do for part 3. All right, let's move on to this next part. And so on this next part, we see that we have evaluate each expression if b is negative 4 and m is positive 3. And so all this is asking you to do is it wants you to substitute these variables with these numbers. So m can be substituted with 3, meaning we replace m with 3. And so if I do m minus b, m becomes 3, minus b, which in this case b is negative 4, and so minus negative 4. And so 3 minus negative 4, subtracting a negative is the same as adding a positive. So this is 3 plus 4, which just equals 7. What about b plus m? Well, b is negative 4, m is 3, so this is negative 4 plus 3. And again, all I'm doing is I'm substituting b with negative 4 from up here, and m with positive 3. Again, we're just using these two numbers throughout these problems. And so negative 4 plus 3 is just going to be a negative plus a positive, or a positive plus a negative. Take the sign of the largest numeral. Largest numeral is negative 4. And then subtract. 4 minus 3 is 1. Now when we go down here, we get b, right, which is negative 4, times m, which is 3. A negative times a positive is equal to a negative because you're multiplying opposite signs. And then 4 times 3 is 12. So that means negative 4 times 3 is just negative 12. And so this one's important because this is m times negative b. So we want the inverse of negative b. So what ends up happening is this becomes, right, m times negative b. And so m is equal to 3 times negative b. In this case, b is just going to be negative 4. And so notice how we didn't change the negative, but we did substitute b, right, and made it negative 4. So this just becomes 3 times a negative is a positive, so it's just 3 times 4, which is just 12. And so for these down here, I suggest you guys try these on your own. Here are the answers if you guys are able to go through it, but we want to save time for the video. All right, so for this one, we're going to choose a few of these, not all of them. And so I'm going to choose these 3 here to go over because they're the hardest ones. And so if we do this, right, we do know a negative times a positive is a negative, so we know the answer to this one is going to be negative. So I can write this as negative 8/4 times 1 over 2. Now you can make this a fraction, right? Or you can make this a decimal multiplied, or you can just understand that you can put this over 1, just like before. Whenever you multiply something that's not a fraction, you can put it over 1 and then just multiply across. Negative 8 4/10 times 1 gives us negative 8 4/10 over 1 times 2, which is 2. And now we can simplify this. Some of you guys can do this in your head, but we're going to do this on the side. So a negative divided by a positive is just a negative, so we can put the negative instantly in our quotient. 2 goes into 8 4 times. 8 minus 8 is 0. When you get to your decimal, you bring it up. Carry down your 4. 2 goes into 4 2 times. So we end up getting an answer of negative 4 2/10. And that makes sense because what's half of negative 8/4? Well, half of negative 8/4 is negative 4 2/10. Now going down to the bottom one, we're multiplying some big fractions. And so when you're multiplying big fractions, big decimals, we're multiplying big decimals. What we want to do is put the decimal on top times 2/5. And so a negative times a positive gives us a negative, so we know our answer is just going to be negative. And so we want to keep track of our decimal places. This is negative 3 25/100ths. And so our decimal terminates in the hundredths place. So that means we need to keep track of 2 decimal places. Here we have positive 2 5/10. We have 1 decimal place here, which means when I get down to my product, I need to bring back 3 decimal places. And so I start. 5 times 5 is 25. I regroup my 2. 5 times 2 is 10, plus 2 is 12. Regroup my 1. 5 times 3 is 15, plus 1 is 16. Bam. Now I'm moving over from the tenths place to the ones place. So whenever you move over a place value, you need to add a placeholder. And so now you start, right? We're done with these, so I like to cross those out. You can cross this out because you're done with that one. 2 times 5 is 10. Regroup my 1. 2 times 2 is 4. Plus 1 is 5. 2 times 3 is 6. And now I can add these together. 5 plus 0 is 5. 2 plus 0 is 2. 6 plus 5 is 1. Regroup my 1. 1 plus 1 is 2. 2 plus 6 is 8. And now we don't want to forget about our decimal, right? So what we need to do is we need to factor in. We had 2 place values here, so that we have the 2 here. 1 place value here, so we put 1. 2 plus 1 is 3. So this means I need to add back in 3 place values. 1, 2, 3. Notice how I'm using underlines. So we go 1, 2, 3. This means my answer is negative 8 and 125 thousandths. And this makes sense because this is in the tenths place. Here is in the hundredths place. So hundredths place is 1 over 100. Tenths place is just 1 over 10. 1/100th times 1/10 is just 1 over 1,000, which is why this decimal terminates in the thousandths place. And so finally, on our third one, we are dividing fractions. And when we divide fractions, we need to multiply by the reciprocal. And we learn this as keep, change, flip. And so you always keep your dividend, so you always keep the negative 5 over 2. You're now going to want to change from division to multiplication, and then take the reciprocal of 13 over 4, which is just 4 over 13. And now with fractions, we know we just multiply across. But here we have a negative times a positive, so we know our answer is just going to be negative. So 5 times 4 is 20. 2 times 13 gives us 26. And that's our answer. Let's move on to the next one. All right, so for here we have a bunch of one-step equations, but I'm only going to go over these 4. And so what we need to understand when going over one-step equations is we start by organizing the math. And we always want to do the inverse operation to get x by itself. And so this is negative 1/2 times x. So to get x by itself, we need to divide both sides by negative 1/2. And so again, this fraction bar here means division. And that's how I'm showing, right? I'm getting rid of negative 1/2 times x by dividing both sides by the number that's attached to x. So bam, we end up getting x is equal to, right, 1/4. What's important is you know your numerator is your dividend, your denominator is your divisor. And so what you're doing is your dividend 1/4 divided by your divisor of negative 1/2. And so when you're dividing fractions, you need to multiply by the reciprocal. So it's just keep, change, flip. And so we keep our dividend of 1/4. We change from division to multiplication. And then take the reciprocal of negative 1/2, which means we flip it to get negative 2 over 1, which just ends up equaling negative 2/4, which can be simplified by 2 to be negative 1/2. So our answer is just negative 1/2. All right, going on to our second one-step equation. Here we have negative 2x is equal to 7, right? So this is negative 2 times x. And so what I can do is divide both sides by negative 2. And so negative 2 divided by negative 2 is just positive 1. So I'm left with x is equal to 7 over negative 2, which that's an improper fraction, and I want it as a mixed number. And so a strategy we can do is ask ourselves, how many times does 2 go into 7? And so 2 goes into 7 3 times. 3 times 2 is 6. 7 minus 6 is 1. And so here we have our remainder. So this ends up becoming our whole number. Our remainder is always our numerator. And then our divisor is always our denominator. And so this becomes negative, right, because this is still negative, 3 and 1/2. And so this means x is equal to negative 3 and 1/2. And so finally, down here, we have x plus negative 2 is equal to negative 6 and 5/10. Well, our goal is to get x by itself, so we need to add by the additive inverse here, right? You could subtract by negative 2, but subtracting a negative is the same as what? Correct, adding a positive. So we can add positive 2 to both sides. Cross this out. And then I like to do this step where I show an arrow to carry down my x and get x is equal to negative 6 and 5/10 plus 2. Take a negative plus a positive, or a positive plus a negative. Take the sign of the largest numeral and subtract. So 6 and 5/10 minus 2. You keep it by place value, right? Because the 2's in the ones place, the 6 is in the ones place. 5 minus 0 is 5. 6 minus 2 is 4. Bring down our decimal. Our answer is negative 4/5. So x equals negative 4/5. And then finally here, our goal is to get x by itself, and this confuses kids sometimes, right? You want the negative 2 to be 0. And so again, we're adding 2 to both sides again. These cancel out. Carry down your x. And so 2 plus 1/2 is just 2.5. You don't really got to do anything other than that. So x is equal to 2.5. And that was problem number 6. All right, so in this problem here, we have a tank of water is being drained due to a problem with the sensor. It does not start working until some time into the draining process. The sensor starts its recording at time 0 when there are 770 liters in the tank. So that's the total amount when it started. Write an equation to represent the drain emptying at 14 liters per minute. And so since it's emptying, ask yourself, is that positive or negative? Well, you know it's negative, so you know this is just negative 14. And so what's important is your dependent variable and independent variable. Whenever you see the word something per something, that's always your dependent variable per your independent variable. And so our dependent variable is liters. Our independent variable is always time, right? So that means minutes is our independent variable. And we're actually given our constant proportionality here. We're given that it's 14 liters per minute, that it's emptying at that. So K is just negative 14. And we remember our equation is just always our dependent variable is equal to our constant proportionality times my independent variable. And your constant proportionality is just a constant rate, meaning that every minute goes by, the same amount of liters is emptying. That's constant. And so our dependent variable is our liters. So this is just L is equal to our constant proportionality of negative 14 times my independent variable, which is M. And so we can use this information to help solve down here. So given the drain empties the tank at a constant rate of 14 liters per minute, complete the table. And we instantly see here that we know when our independent variable is 1, our dependent variable is going to be our constant of proportionality. And so I can write this as our starting point, which is 770, right? So 770 plus our independent variable times our dependent variable gives us our change. And so 770 plus 5 times our constant proportionality of negative 14. And so 5 times negative 14 is just negative 70. And we know that because when we go from left to right on a table, you're multiplying. So 5 times negative 14 is just negative 70. And so this means that 770 plus negative 70 just ends up giving us 700. And so we do it again. What's the change in water? Well, we can apply our constant proportionality of negative 14. 10 times negative 14 is just negative 140. And so to show this as an expression, you have your starting point of 770 plus the amount of minutes that changed of 10 times our constant proportionality of negative 14. And so then this tells us that the water in the tank is just 770 plus negative 140. Take a positive plus a negative, or a negative plus a positive. Take the sign of the largest numeral and subtract. 0 minus 0 is 0. 7 minus 4 is 3. 7 minus 1 is 6. So that's just 630. And so then when you move here, right, we're saying that later someone wants to use the data to find out how long the tank has been draining before the sensor started. complete this table. What's important is you're still using the 770. And so again, -2 times -14 is just positive 28. And so again, this is 770 plus your independent variable of -2 times your constant proportionality of -14. And so 770 plus 28, right? We can do that on the side, or you can realize that it's just 798. And so you would do that for each one. And so again, if we went to -5, right? -5 times -14 gives us positive 70. And so what that means is that you would be adding 70 onto 770, which is just going to be 770 plus our -5 times our -14. And so 770 plus 70 just gives us 840. And so that means 5 minutes before the tank started registering, we had 840 liters. And so here, if the sensor started working 15 minutes into the tank draining, so these are what we're waiting for, right? And so this would be our -15. The reason why is because 15 minutes passed before this tank started recording anything. And so this is the part where it started recording. 1 minute passed, it decreased. 5 minutes passed, it decreased. These are the minutes before we knew that it was draining. And so here it would just be -15 times -14, which -15 times -14 we know is positive. And so 4 times 5 is 20. Regroup our 2. 4 times 1 is 4, plus 2 is 6. We move over a place value. 1 times 5 is 5. 1 times 1 is 1. This just becomes 210. And so we would add 210 to our amount to get that there is 980 liters in the tank 15 minutes before the sensor started to work. And we do have one more problem here. This one is just thinking about money. And so, right, find the table, the missing amounts. So here it says your transaction amount is you're depositing 200 because positive is depositing. So deposit equals positive, withdrawal equals negative. And so here, right, you deposited 200, so your account balance is 200. You withdrew -147. And so if you did 200 minus 147, you get 53. And so then you're depositing 90, so 90 plus 53 is just 143. And then I want you guys to finish these parts on your own. Good job, y'all.